Alright, we got geotrig lesson 14 here. Day 1, we're going to talk about sine, cosine, and tangent. So we're going to talk about Sohcahtoa here. Sohcahtoa is a very important thing that we need to know because this is going to help us identify sine, cosine, tangent, and all of its ratios that are associated with sine, cosine, and tangent. So there's a couple different ways that we can use to remember this. I'm not going to write it all down, but I'm just going to write, use to get the trig ratios. Now there's one way that I learned from a prior teacher to remember that this can be used as an acronym. The acronym would be some old hippie caught another hippie tripping on acid. If it allows you to identify that it's SOH, CAH, and TOA, then use what you want to. But it's Sohcahtoa. And so why is this important? Well, sine, cosine, and tangent are ratios, and they're all based off of a triangle. And of course, these triangles are all right triangles. So down here, I'm going to fill this in. This is a right triangle. And I'm actually going to go even further here and say that these ratios are used on unknown angles. So we are going to say it's the sine of an angle, cosine of an angle, tangent of an angle. And what this is, since we don't generally know what they are, we will use theta. Now, theta is like the x of polynomials. When we talk about equations and stuff, we always say y equals some x's. In this case, now we're going to say it's of theta. So sine of theta, cosine of theta, tangent of theta. And so that allows us to locate theta in a triangle. So that way we have our ratios. So sine is based off of the first three letters. Sine, we affectionately use S-I-N. That is not for sin, that is for sine. We're in math class. And so the sine of theta is going to be O and H. Now, if we look back at our triangle here, I think we could all agree that the longest side is always going to be our hypotenuse. There are two other letters, O and H, and these on all three of our Sohcahtoa pieces, and they stand for opposite and hypotenuse. So if you have theta here, the A side opposite is opposite. The side that's next to it, whoops, I messed up, guys. It is not hypotenuse there, it's adjacent. It's adjacent. So the side next to it is adjacent. Sorry, didn't catch that until I looked again. So opposite, adjacent, hypotenuse. Those are the three things that are used here. So sine of theta, which is sine, is equal to the ratio of O, or opposite, over H, which stands for hypotenuse. Oops. Hypotenuse. Cosine, we use C-O-S, cosine, not cos, cosine. And that is A over H, or that is the adjacent over hypotenuse. And tangent are the last three letters, which is O over A. So tangent is actually just tan of theta. And that is, sorry about the noise, but that is the O for opposite over adjacent. So those are the three ratios based off of Sohcahtoa, and the letters that help us identify the corresponding pieces of the triangle that we are talking about. Now, before I move on to the next slide to start talking about the things on there. I'm going to talk about something that's on that slide, but I need to use this particular triangle. If we were standing and talking to each other, we'd be face to face. So if you can visualize, like, this is me and this is you, or vice versa. And if I was standing here and I said point left, my arm would point this way. But since your face, we'll put faces, right? Faces are here, you would be like, hey, left is that way. It's because we're facing different directions. We are both right, we both pointed left, but since we're facing in different directions, therefore we have different results. It's our perspectives. So I am going to say that we also have the same thing happening here. In this triangle, if I am at theta, opposite is the angle that it opens up to, adjacent is the side, hypotenuse is always the longest leg, or the longest side, sorry, not the leg. But if I happen to say, what if I was here and I call that alpha? Remember, angles can be called anything, just like any other variable. So if I was at A, or alpha, opposite to this angle is actually here. So that's why I'm color coding. This is now opposite. The side that's right next to it is adjacent. And the hypotenuse is still the hypotenuse of the triangle, longest side. So it's very important that you understand that if you're talking about angle theta, opposite and adjacent are different than if I'm coming from the other side or the other angle. I'm facing a different direction. So that's very important. So why is that important? Why did I talk about it here? It's because of this line right here. This line says that the opposite and adjacent sides are directly related to the angle you choose, which means if I'm at M, then opposite is the 3, X is the adjacent. If I come from up here in this angle, X is now the opposite, adjacent is the 3. Very important that you make that switch. So then working our way up from the bolded section there, we're going to talk about this right here. Very important. Not only is the fact that opposite and adjacent will switch according to what angle you are from, then this makes it all the more important that when you're working with sine, cosine, and tangent, that you must first mark out, or mark off, or work from a particular angle, and then you can locate and write opposite, adjacent, hypotenuse. I want you to physically write them down, and when we get to the example below, you will see that. Because if you don't write these things down, you are more likely to make a mistake. And the whole idea is, again, to not make mistakes. So you're going to write according to what angle you're from, opposite, adjacent, hypotenuse, and you will write Sohcahtoa, because that is the key to all the right triangle trig. Now, the very first top thing up there is pretty important as well, and it's saying that we can use sine, cosine, and tangent of an angle. So I can say sine of 60, cosine of 60, tangent of 60 degrees. And I could tell you there's a ratio associated with that, square root of 3 over 2, or 1/2, or square root of 3 over 3. So we can find those things. But we can also go the other way. If I gave you the sides, you would be able to find the angle. So, I can't squeeze it up top right now, but if I said sine of theta is equal to 1/2, we should be able to find theta. Now there's important steps into this. Number one, I need to make sure everybody has their calculators in the right mode. And so to do this, if you are using a graphing calculator or the TI-30X2, I think it's called, the ones that have the different colors to them, you guys hit mode and make sure you're in degrees. Most of us are probably in degrees, unless we did some of this work maybe last year or the year before. Now, if you are using the standard gray boxes, most of the time when you hit clear all, it does reset to degrees. Sometimes it does not. So you will have to hit the DRG button until it says degrees. Should be a little button above your window. Actually, back to the graphing calculators, that the DRG button should be on those colored TIs as well. If you're using a graphing calculator, you have to use mode. So hit mode, and then make sure there's about 2 lines in there. On the second or third line, there will be radians and degrees. Make sure that it's in degree mode, so it's highlighted above degrees. Hit enter, and then second, quit. You want to be in the right mode. Make sure to pause the video. Make sure everybody is in that right mode. So now that we're all in the right mode, I hope, we can move on to solving for theta. Now, sine itself is a function, and so we know how to get rid of functions. If this would have been something like x squared or a square root or multiplied by 2, you guys would be like, oh, divide by 2, take the square root, square it to cancel things out. Do the inverse. Well, the thing is, I cannot divide by sine. You can't just divide by sine to cancel it. So you need to multiply by its inverse. And so that's what these things are. Each sine, cosine, and tangent function has a sine inverse, cosine inverse, and tangent inverse. Those are the second buttons underneath sine, cosine, tangent. Some calculators have a trig area, so you'll have to find that according to what your calculator is. And so what we're going to do is we're going to apply what we do to one side, we have to do to the other. The sine inverse and sine will cancel each other out. But what I did to one side, I have to do here, and I'm putting it out front, so that I end up with theta equals sine inverse of 1/2. So now, again, it really does depend on what calculators you have. If you have a graphing calculator, or if you have the TI colored scientific calculators, you can go second sine, which will be the sine inverse, put 1 divided by 2, and then enter. Remember, 1 divided by 2 is you're dividing. You don't need to use that fraction button that everybody's searching for. You're more likely to cause yourself trouble if you can't. You got to learn not to use that fraction button. A fraction is dividing. 1 divided by 2 is 1/2. Or if you know what 1/2 is, it's 0.5. So sine inverse 0.5, enter. You should have an answer. And the answer is 30 degrees. Now, if you're using the gray box calculator, you have to do things separately or a little bit differently because your calculator can only do one thing at a time. For you guys, you have to do 1 divided by 2, enter. Then hit second sine or sine inverse, enter. That should also result in 30 degrees. Pause the video, make sure everybody help each other out, make sure you get this right. You must get 30 degrees before moving on. So, why is this all important? What can we do with it? Well, I can solve triangles like this. I can find angle M and I can find side X. Now, if I gave you this particular problem without even telling you about Sohcahtoa and right triangle trig, everybody in that room should be able to say, hey, I know what X is. Hey, I can use Pythagorean theorem. X squared plus 3 squared equals 7 squared. Solve for X. We've done that many times. We've done it before. But the thing about it is, we just learned how to do trig. There's got to be a way to solve using trig. So we're going to find M using the same process that we just did up here. I shrunk it, put it over here. And then once we find M, I'm going to be able to find X. Because you need 2 of the 3 pieces in any trig function to make it work. So if I'm going to talk about M, I have 3, 7, and X. I must label them accordingly. So if I'm at M, across from M is the opposite. 7 is the hypotenuse, and it means x is the adjacent. That allows me then to say, wait a minute, I'm going to use Sohcahtoa, and if I use Sohcahtoa, I then would say, wait a minute, I know 3, I know 7, which is opposite hypotenuse, that is opposite hypotenuse, I'm going to use sine. So the sine of m is equal to opposite 3 over 7. And just like the problem above that we just did, to the right, I guess, I need to get m by itself. And to get m by itself, I will take the inverse sine. And if I take the inverse sine, gone, m equals the inverse sine of 3/7. And if you put that on your calculator, using the same methods that we just used before, you should get something like 25.4 degrees. That is rounded. Now here's the thing. 25.4, make sure everybody gets that, so I have to pause the video, that's fine, is the fact that that's an approximation. That is not a nice answer per se. It's not bad, but if I had to, or not had to, I guess, or had a choice, do I use 25 as a calculation, 25.4, to find other numbers, or do I not? I would choose not to use that to find other calculations. Because what if I'm wrong and it was not 25.4? Then every number based off of that will also be wrong. But since we're learning about trig and I want you to apply the trig properties, we are going to use angle M, or 25.4, in our calculations. Otherwise, I think I would use Pythagorean theorem to get the exact answer. So, going back to M. Here's M. X is the adjacent. I have an opposite and I have a hypotenuse. And if I go back to Sohcahtoa, I can actually use cosine or tangent. But the piece I know is actually x, and that is the adjacent. And if I am going to use a fraction to solve, I'm thinking adjacent on top of a fraction, which is the unknown, on top would be good. I know the hypotenuse, so I'm actually going to use cosine of 25.4 equals x, adjacent, hypotenuse, 7. And now I can solve this. To get x by itself, I'm going to multiply by 7. And so therefore, I get x equals 7 cosine 25.4. Or it's about 6.32. So it's about 6.32. And it's not degrees because it's a side, it's 6.32 units. So that's how we're going to use trig to solve for sides or for angles. Sometimes you take the inverse, sometimes you take it in the forward direction. So the homework that you have to do today is lesson 14, page 113, day 1, 3, 9 through 12. Have a great day.